Hello, everyone. Thank you for joining us. My name is Ricardo Villarreal. I am a product manager in Azure for Operators. We are a team that is helping telco operators to build their networks in the cloud. Together with Cesar, we are going to be talking to you about programmable networks, about network APIs, and about an exciting product called Azure Programmable Connectivity, APC for short. So the first thing I want to talk to you about is about a transformative shift in how we are developing and deploying applications, how they are being developed and deployed. What's happening, as you can see on the left-hand side of this slide, is that applications nowadays, they are running on many different places, on many different compute places. They could be running on a cloud, they could be running on a private MEC, they could be running on the space, or they could even be running, obviously, on a device locally. And many times what's happening is that different components of the same application are running on different places. So effectively, the workloads are spread across. The workloads of these applications are spread across all of these different compute places. Now, at the same time, the networks that are empowering these applications, they are many. There's a multitude of networks making these applications work. So these applications might be using public networks, they might be using private, wired, again, even satellite networks. Something important to mention is that these networks are not just passive channels. They are actually programmable networks. They can interact with the applications. So that's the reality that we are working with. So basically, we believe there is something missing, something that we need. So the developers need the best tools to access these networks. The developers need tools to write and deploy network-aware applications across diverse networks with a consistent experience. This is the challenge and the opportunity that we are working with. So now, let me tell you a little bit more about the programmable networks that I just talked about, the programmability of these networks. Effectively, what is happening is that the telco operator networks, they are transforming into what we call digital platforms, into actual digital platforms. So this is going by certain steps. The first thing that is happening is telco operators, they are creating new network capabilities. Just quick examples, these are capabilities for mobile applications like you can tell the location of the devices that are connected to your application, or you can use anti-fraud capabilities, obviously to prevent fraud, or you can improve the connectivity of a specific device on demand, only for the time that you need it. So these new network capabilities are being created by the telco operators. The second thing, as you can see in the box in the middle, is these capabilities are being exposed to the developers via APIs. So effectively, what is happening, as you can see in the right-hand side box, is that the applications and the networks are actually being integrated. The networks are becoming part of the digital platform on which the applications are running, together with the cloud and together with any other platform that the application might be using. The network is also part of this digital platform. Something important for all of this to work is standardization. So these network capabilities and the network APIs used to expose these capabilities have to be standardized. That is critical. There are two main groups working on this. One is 𝗦𝗲𝗀. 𝗦𝗲𝗀 is an open source project in the Linux Foundation, and they're working together with the GSMA. They have an initiative called Open Gateway, and these two bodies, what they are doing basically is, as you can see here in the slide, they are orchestrating collaboration. First of all, they are orchestrating collaboration amongst industries, and I'm talking about not only the telco operators collaborating amongst themselves, but also with technology companies, with the hyperscalers, with the network equipment providers, and even with the technology companies behind the creation of these mobile applications. Second thing you can see is they are creating the common API definitions, the standardization that I'm talking about. This is very important, that a developer has access to the same capabilities, to the same network APIs across different networks. That's what's going to make valuable these capabilities. If you can only access a capability in one network, then obviously the value diminishes a lot, right? So you have to be able to access these capabilities across many different networks. And then the third thing is obviously we are working with the actual users of these capabilities. We are exploring the most impactful use cases for this. So let me tell you now how we see the challenges and how we are solving them. First the challenges and then the solution to them, right? So the first challenge lies on the developers. So they need a seamless experience to access these capabilities that I'm talking about, right? They need to be able to access them easily through a consistent experience. The second challenge is for the telco operators. They need access to the ecosystem of developers. They need access to the users of these capabilities, right? So what Azure is doing, and I'm going to tell you a little bit more about the product that we are using, but what Azure is doing is we are providing developers with a streamlined experience to access these network APIs, right? We are abstracting the complexities of using these APIs. And also for the operators, we are helping them to offer these capabilities and also to differentiate their offerings. So how are we doing this? We are doing this with Azure Programmable Connectivity, APC. It is the box that you can see here in the middle. So what APC does is mainly two things. It unifies and it abstracts. When I say it unifies, you can see that we are working with many operators. The ones you see here are the ones that we've been collaborating with, but we are expanding these collaborations. So basically all of these telco operators, they are exposing many APIs and they multiply if you take into account that there are many operators as well. So what we do in the unification is we provide only one interface. So the developer up here, as you can see in this example of applications, the developer only has to access these APIs, all of them through one interface. We're going to show you, we're going to tell you more about that, and we're going to show you some demos of how that is actually happening. But that is the unification we're talking about. The developers only have to write code once. And then the abstraction that I mentioned, the abstraction is because we are presenting all of this as an Azure service. The contracting takes place from within the Azure portal, and we're going to show you that. And then we're going to show you how the APIs are actually called. Something I want to mention is a key element of this platform of APC, of Azure Programmable Connectivity, is the APC gateway that you can see here in the middle. So in this diagram, what you can see is on the left-hand side, you have a modern connected application running on the cloud. This modern connected application, let's say it's an online game. It's connecting to different mobile devices, right? As you can see on the right-hand side, they are running the client, and that is connecting to the modern connected application. Now, the modern connected application wants to access the APIs capabilities from all the different operators. So what the APC gateway does, it is the one interface that I mentioned before. It is the one interface that the modern connected application has to call into. That's the only one that they're going to be using. This gateway is managing the credentials. Different credentials are needed to call different APIs from different operators. And then the APC gateway is also doing smart routing. It knows what operator it has to call. It has to direct the API call towards. Just to make it a bit more tangible, I mentioned this briefly before, but these are the APIs that we are focused on at the very beginning. Our initial focus is on anti-fraud. So there are three APIs that we are focused on. One is SIM swap. It detects when the SIM has been swapped. It's a capability that allows an application to understand when was the last time a SIM was swapped in a device. This is a very common scenario in fraud. Another one is number verification. The application can verify the number from which a connectivity is happening. This is usually achieved through an SMS message, but in this case, it is achieved more elegantly and more effectively through the network. The network can confirm without using an SMS that the connectivity is happening from the actual device. Another one is device location. Device location can be used for many things, but in this case for anti-fraud, obviously an application can understand where the connectivity is happening from, where the device is actually located. And then for the near future, I'm just mentioning some of them here: quality of demand, carrier billing, discover the optimal latency endpoint. Quality of demand, just as an example, is the ability for an application, again, to improve the connectivity of a specific device only for the time that is needed, on demand. In a second, I'm going to show you how these APIs are contracted through the Azure portal. But once you have contracted them, the way you can use them, the way your application can call these APIs is through SDKs. We are providing an SDK currently for .NET, and then in the future we're going to be using JavaScript as well. I'm sorry, Python as well currently, and then in the future JavaScript. But also you have the ability to use any language that is capable of invoking an HTTP services. You can use the HTTP REST APIs. So now I'm going to show you a demo of how you can contract these APIs in Azure. So the first thing you have to do is you have to go to the Microsoft Azure portal. There you can find the gateway in different ways. You can search for it, APC. You can search Azure Programmable Connectivity that way. So the first thing is you find it, you click on it, you create a new APC gateway. It's going to take you to a series of steps. The first step is going to be to create an APC gateway. You're going to have to choose a subscription, a resource group, and then in which region you want this APC gateway to be running, and give it a name. Once you have entered all the information, you click Next. And then it is the time to select the APIs that you want to contract. These are the three APIs that I mentioned before. Is the initial focus of our product. You can click on SIM swap as an example. You're gonna see a screen with the countries where we offer this. In this preview version that we have it available in Brazil and in Spain. You can see the different operators here, and you can add whatever operator you want. You can see the plan details, the price for each of these. You can browse to a different country and see the plan details. And then you can start selecting them. In this case, I'm going to select them all. Once you have selected them, you can see different rows showing your selections, and you can modify these, you can delete, or you can go back to make any modification. You click Next. Here we have to collect information on behalf of the telco operator that is offering these APIs. They need this information in order to provide these services. Once you have entered all the information, we click on Next. And now the next step is you have to agree to the terms and conditions for this. We do this on behalf of the telco operator. These are terms and conditions between the telco operator offering the network APIs and the developer. You gotta click on each one of these. The terms and conditions would be presented as text if provided as such by the operator, or as a link that you can check. You have to agree to all of them. The next step is a review and getting ready to create all of the resources. So you can see the basics about the network, the gateway, the APC gateway, the APIs that you are contracting, your organization details, and the application details. If we are ready, we click Create. As you can see on the right-hand side, the deployment is being initialized, submitted, and created. The first thing to be created is the gateway. Deployment is in progress. And then the API connections are created. They are being checked. We can see in the deployment details that all of the API connectivity, all of the API connections were created and the gateway was created. Thank you. With this, I'm going to pass it over to Cesar, who is going to be doing some demos.
Cool. Thank you, Ricardo. So I'm going to show you how to architect and develop applications using APC. The first thing that I want to show you today is a demo about anti-fraud with a banking application. So this is a demo, live demo that will show you the different use cases and scenarios interesting, and then we'll get into the details.
Here we have a demo app for a fictional bank for microloan requests using any mobile operator that supports this API. This app ensures security by verifying the user's phone and line information through APC and the network operators. So on this screen, users are required to enter their residence location, and the app verifies that the provided residence location is in the same area or country where the actual device phone is. If not, the app won't allow to continue for the loan application request. But since GPS coordinates can be hacked, the app uses the backend APIs in the cloud, ultimately connected to the operator for that validation. Next, user enters their phone number, which will be validated at the backend with the APC APIs and ultimately by the operator. Afterwards, they can select their desired loan amount and also its purpose, and then click on Next. But before moving forward with the loan request and to prevent fraud, one more security check through APC is performed, which is SIM swap. And if SIM swap was not recently changed, then users can then fill in their personal information to finalize their loan application.
And now I want to explain what kind of architecture you need to do when creating an application. The first thing is you, of course, create the mobile application on the left. That can be any mobile app, for instance, using React Native or any other language. And then you have to call your service. And you need to create a service, a backend service to deploy in the cloud. This would be a customer service that you can deploy, you can develop with C# and .NET. And it needs to be in the cloud so you can interact with Entra ID and get the tokens for authentication. And then your services will use the SDK, APC SDK, or REST APIs from the APC gateway, which is something that concept was explained by Ricardo previously. So we consume APC gateway, and then the gateway is going to redirect to the right operator being used by the user. In this case, for the demo, we have working with Telefónica and Orange, right? So this is the end-to-end architecture. I want to focus or highlight again that most of your code needs to be deployed as a web API in an Azure web app, right? It can be C# or any other language, right? So, and then about the operators, we will have many operators as well, not just the two that I mentioned. Any language for the mobile application in the client. And you could also use Python for SDK or any other language if you are just consuming the REST APIs, right? So let me do the first demo using the SIM swap detection API and using the SDK for Cesar, right? So here it is. In here, first thing I want to highlight is that this is the kind of the code that you would implement in the web API as a service, but for simplicity, we are running this code in a console application in Visual Studio. First thing that you would notice is that we are using the SDK, Azure Programmable Connectivity. That's the namespace for the SDK. And let's hit F5 and start debugging while I explain the code, right? So the first point that you will see here in a minute. Okay. Is the URI to the gateway, right? We need to know where to talk to the gateway, and then the secrets or IDs that we need to use in that gateway. And once we have that, you will see that we are using this class, which is part of the SDK, Programmable Connectivity Client. And through that class, we will interact with the APIs. So it's a class that makes it a lot simpler than if you were using the REST APIs, right? So the first thing that I provide for this API is going to be a telephone number for the line where I want to check if a SIM swap happened. Why would I want to check if a SIM swap happened? Well, the reason is because you might want to check is if anyone, like a hacker, swap to another SIM, like they convince the operator saying that hey, I'm this guy and I lost my SIM card, I need a new one, and then they could do two-factor authentication instead of you, right? So with this app and this API, we are checking that your telephone line didn't have any SIM swap recently, right? And this is the phone number that we want to check, right? And once we provide that information, we are using this API, get SIM swap client and verify to check if the SIM swap happened, right? And you can see now that I got the result in here that there was any SIM swap that happened recently in the last 3 days, I think I put, right? Okay, so now I'm going to do a quick demo, same API about SIM swap, but in this case, using the REST API and using Postman. So you can see using Postman here that it's using SIM swap verify, right? And telephone number, same data. And then I will just hit send. So we are consuming this API through HTTP. And it's checking if this telephone number had a SIM swap lately. And as you can see, it says that it didn't, which is good. And that's it. Like in the same way that you can also use it with Postman, you could use any class in Python or .NET or any language to consume REST APIs. The next demo I'd like to show you is about the second API, which is a phone number verification API, but in this case using REST APIs instead of the SDK. So I will use the HTTP client class.
Okay, so in this demo, I'm going to show you how you can use the APC number verification API so the app can check that the cellular network in use is using a specific phone number. The reasons why an app might want to do that is for security and tracking reasons, or also for having a simplified two-factor authentication login. For instance, there's no need to send a text message with a code for the user to type in the app if the app can directly check that the user is using a particular phone number when connecting, right? And then that number could be already in the user's profile, right? So that can be checked. So in this case, I'm consuming the HTTP REST API. You can see here in the Visual Studio solution that I'm just using regular Azure identity packages and .NET framework, but I'm not referencing any other SDK like the APC SDK, just plain HTTP, right? So let's hit F5 for debugging. You can see now that I'm using HTTP client class. So it's a regular class to consume HTTP services. And you could do something similar with other languages like Python or Java, Rust, Go, etc., right? Let's hit F5 again. And here we have the telephone number that I want to verify, right? I want to verify that I'm connected through the network using this phone number. And since this is related to a phone number that I need to be using, it's mandatory that I'm connected through a hotspot, in this case, with my environment, right? So you can see here that I'm connected with an iPhone as a hotspot, right? So then hit F5 again and continue. And then you can see that the verification result that we get is true. So we are really using that phone number when connecting through the network, and you can also see it in the console application. And if I run this same code with a different number, then I would get a false return value, right? And that's it. Thank you.
And finally, as the third API, and because of time restrictions, I want to highlight the code that you would use in order to use the device location API. So in this case, you want to know if a particular location for an API is right, or if it's being hacked, right? So basically, it's similar code that I showed you with the SDK, but then you provide the coordinates, latitude and longitude of the GPS to validate, and then the telephone number to validate for that coordinate, and it will return true or false, right? And so with that, you are sure that a particular location is right, and it's not just provided by the phone itself, GPS, but also validated by the backend, right? And with that, Ricardo, you can take it away from here.
Yes, thank you, Cesar. So I'm going to talk about, just very quickly, about some examples that are happening already. In Brazil, we have Itaú, one of the largest banks that operates in the country and also in Latin America and other countries. They are enhancing the protection that they provide to their customers. They are using already location verification for the transactions that are happening in the mobile devices that their customers are using, so they can understand where the connectivity is coming from. Obviously, they are using this information together with some other information to assess how risky or how fraudulent transaction might be. Another example I want to give you is 𝗦𝗽𝗲𝗀𝗀𝗶𝗶𝗄𝗏. They are a media and entertainment company operating in many countries also. The one use case we are working with them is in Spain. They already provide intelligent home network security. They provide security to all the devices connected in your network in your home, but they are adding the cell phones of every person in the household. So you can add your cell phone, and by adding your cell phone to their platform, they can be using SIM verification, the SIM swap verification, to see if your phone has been hijacked. We just want to thank you for your time. I hope that you enjoyed this session about programmable networks, about network APIs. The first thing I want to highlight is that you can go to GitHub and grab the demo app code.
Yeah, about that, when you go to that GitHub repo, you'll be able to grab the demo application code, but not just that. Also, we're putting in there a hands-on lab documentation, so you will have everything step by step for the three APIs. We're using the SDK or using REST APIs, everything in a single document, very much detailed.
You can learn more about APC in general by going to our latest blog. You can also watch some videos that we have. And it would be great if you apply and sign up for our public preview of Azure Programmable Connectivity. You can go to this link to do so. Thank you very, very much for your time.
Thank you.